Hello folks, we are back with our next video where we are going to do this problem number 8. It says that it is 1 minus cos x over 1 plus cos x dx. We'll be doing the problem, check how we can do it. Of course, we are going to use the 11th standard formulae that we had used, that we had studied in the 11th standard. Those formulae we are going to use and try to solve this. So 1 minus cos x, we all know, we had studied from the 11th standard that 1 minus cos 2x is 2 sine squared x, and 1 plus cos 2x is 2 cos squared x. So we can use that formula here. Of course, it will become half angles. So here it will become 2 sine squared x over 2, and here it will become 2 cos squared x over 2 by these two formulae. 2 can cancel each other, and finally it becomes tan squared x over 2. Since we know that there is no derivative for there is no integral for tan squared, so we have to convert it to sec squared and then do the problem. So let's convert it as sec squared x over 2 minus 1. So therefore you have dx. So therefore you have sec squared x over 2 dx minus dx. Now sec squared, we all know the integral is tan x over 2, but we have to account for the integral coefficient half because there is this half coefficient here, and this is x plus c. So when we rearrange and write, this will be 2 tan x over 2 minus x plus c. That's all. It's a simple problem. Once you know the formulae properly, then it's simple, but otherwise it can be a bit complicated. Then we can come to the 9th problem. See what it says. I is integral of cos x over 1 plus cos x, somewhat like this. Somewhat like this, but then not exactly like this. So we'll try to get the 1 plus cos x in the numerator so that we are able to work with this. So this will be like writing 1 plus cos x minus 1 over 1 plus cos x. What we have done, we have added and subtracted 1 so that we can get the 1 plus cos x in the numerator. If that is the case, then we can always write this as 1 plus cos x over 1 plus cos x, and this can be minus 1 over 1 plus cos x. That's how we are distributing the term into two parts. Obviously, therefore, this first part will become 1 dx because it will cancel, and the second part will become 1 over 1 plus cos x dx. Now, 1 over 1 plus cos x dx, we've seen it, that it is 2 cos squared x for us. So this is integral 1 dx, but this will become dx over 2 cos squared x over 2. It goes to the half angle by that formula. So therefore what will happen, this is integral 1 dx minus, this is going to be integral half outside dx, and therefore you could call it as sec squared x over 2. That's it. So your work is over. This can be called as x, and this can be called as tan x over 2, because you know that integral of sec squared is tan, but then you have to account for the half, and there is a half here also, plus c. So when we rearrange, I think it will come to x minus tan x over 2 plus c. Why? Because the 2's will cancel each other. Anyhow, I'll just get it cross-checked. Yeah, the 2's, there is a 2 already, and then there's a half coming, so they're cancelling each other, and you're getting this way. So that's all about it. It's quite simple. But we'll go to the 10th problem. Is not so easy. There is a lot of work actually. The 10th problem is sine raised to 4x. Sine raised to 4x dx. So here also let's consider the sine raised to 4 separately, solve it and then get back. Consider sine raised to 4x. Sine raised to 4x for us is sine squared x the whole squared, and sine squared x, we'll use this. So sine squared x means it is 1 minus cos 2x over 2 the whole squared. because with this raised to powers we don't have the integral, so we have to make it linear. So we'll do a couple of transformations and try to make it a linear thing so that you can find the integral. That's our logic. So the powers we don't want, sine raised to 4 we don't want, sine squared we don't want, we have to make it into a linear. So that's what we are doing. So now when we square it, numerator and denominator square, 1 a minus b the whole square, so minus 2 cos 2x plus cos squared 2x over 4. So these terms, because 2 squared, so 4. So what are these terms now? 1 over 4 minus cos 2x, 2 cos 2x over 4. So that is cos 2x over 2. And then this is going to be plus cos squared 2x over 4. Again, we don't want, as I said, we want only linears. So we'll have to work with this term. So let's work with this term and see what comes. You have the 1 over 4 outside. Cos squared we have learned. It is 1 plus cos 2x over 2. So it is going to be 1 plus, it's already 2x, so it will become 4x. You know, the next double angle. So cos 4x over 2. See, when it is x, it will become 2x. Because it's already 2x, it will become 4x. So 2x multiplied by 2, that way 4x. So that way. So now how does it simplify? It will become 1 over 4 minus cos 2x over 2. When we open this bracket, it is 1 over 8 because 4 2s are 8. Again, cos 4x over 8 also. We can simplify these two. Actually, times 2 times 2. So 2 plus 1, that can become 3 over 8. And then you have minus cos 2x over 2 plus cos 4x over 8. That's about it. Now we'll get the integral. So I is the integral of all these terms. 3 over 8 dx, then half cos 2x dx, then integral of 1 over 8 cos 4x dx. I don't know where I can write the integral. I'll try to squeeze it in here. The integral is I equal to, let me write, 3 over 8x. Then integral of cos is sine. So it is going to be minus sine 2x. Already 2 is there and 2 integral coefficient will add, so 4. Then cos 4x, the integral will be sine 4x. Already 8 is there, so 8 times 4, that will make it 32 plus c. That's about it. So this is the problem where we have tried to solve this and get this 8, 9 and 10 over here. With more problems, we are meeting in the next video. Thank you.